Okay, there were actually a couple people second hour that finished the whole worksheet in class, and so you might be able to do the same. I'm not going to show you number 9 yet. After doing these, you should be able to get number 9. Number 11, I think once you look at your notes, I think you'll get it. Yeah, I think you'll be okay. So let's look at number 3. If you still can't get it by the end of class, I'll help you, but I really think you'll be able to do it. So Hannah, if you can't get number 9 later on, I'll help you. But my guess is that after you do this worksheet, you'll be able to do it. Okay. So let's try problem number 3. I'm going to do 3 problems with you in class, and then you're going to be on your own, and you're going to work through the rest of the stuff. We have f of x is x squared plus 3x minus 4 at x equals negative 2. And what we want to do is we want to find the instantaneous rate of change at a given point. In order to do that, we use definition number 2, which is the limit as h goes to 0 of f of a plus h minus f of a all over h. I'm not requiring you to find the actual equation for the line tangent, but rather just the slope of the line tangent. So my a value will be whatever x is. So in this case, I have negative 2 plus h, or h minus 2. This would be. I'm using a graphic organizer to fill out these pieces because a lot of people were confused about where I put what I get where. So f of a plus h, I take this h minus 2 and I plug it into the function, and I get h minus 2 quantity squared plus 3 times h minus 2 minus 4. That's the function with h minus 2 plugged in. And now I have to do f of a, meaning I plug in negative 2 for the function. When you do that, what do you get? Negative 6. I plug negative 2 into this, and I get negative 6. So I have the limit as h goes to 0 of f of a plus h, write this whole thing, and then I have to minus f of a. So if I minus f of a, I'll have plus 6, all divided by h. That's the limit as h goes to 0 of, and now I simplify this. Technically it's incorrect. So that was the question right now. Do we have to rewrite that every time? There is definitely points where we will use this even later on where I would encourage you to write it until you actually plug in 0. I won't try to take points off the test for you by not writing that, but I'm just saying that in your AP work, if you didn't do it, they would definitely take points off. Okay. So we have h squared minus 4h plus 4 plus 3h minus 6 minus 4 plus 6 all over h. Limit as h goes to 0 because I haven't plugged in 0 yet. What goes away? Minus 4 plus 4 minus 6 plus 6. And I'm left with somebody. Yep, minus f of a. So I have h squared minus h all over h. Which equals the limit as h goes to 0 of. Can I divide the h out? Get h minus 1. You now plug in 0. Yes, and what do you get? Negative 1. I did. Negative 4h and positive 3h made negative 1h. That's okay. I'm going to go to my calculator, and I'm going to ensure that I have the right answer. I go into y equals. I type in x squared plus 3x minus 4. I then go second calculate, and I want to find the derivative, and derivative is dy over dx, or number 6. It doesn't ask me what x value, I just have to tell it what x value I want. I wish it would say x question mark or something like that, but I just type in negative 1. and press enter, and it says dy over dx. Whoop, not -1, but the x value that we found was -2. My bad. So second calculate number 6, and the x value is -2. The slope should be -1. Sorry about that. Yep, we get -1. Second calculate number 6, and the x value is at -2. Whoop. There we go. Got it? So a nice way to check your answers, I want you to know that this option of second calculate dy over dx, you should get used to it because there's going to be problems on the AP test where you can't work it out algebraically, and you'll need to do that to save time. So let's move along. Turn over to this page and let's do number 9. 2 times the root of 3 minus x at x equals 2. We'll be done long before lunch, and you'll be able to work before that and afterwards as well. So x is 2, so what's a plus h? A plus h or h plus 2? I always write the h first. Every country. What do you want? Right, Mason? F of a plus h. I take that h plus 2 and I plug it in. 2 times the root of 3 minus the quantity h plus 2. What is f of a? So I have the limit as h goes to 0 of 3 minus the 2 is 1, and I'll have a negative h. So I'll write 2 times the root of 1 minus h. Minus 2 all over h. Everybody okay with what I did? Three minus h plus 2. The 3 minus the 2 will give me 1, and then I have a negative h. And then minus 2 because of the minus f of a. All right, so how do I reconcile this? What do I conjugate, baby? All right. One is h goes to 0 of times the root of 1 minus h minus 2 over h times conjugate is 2 roots of 1 minus h plus 2. All right, got it. Okay, so I multiply and I end up with the limit as h goes to 0 of the 2 times 2 will give me a 4. The square root will go away, 1 minus h. Conjugate means the middles cancel out, so I'm just left with the end, which is minus 4 over, be very careful with this bottom, h times the quantity 2 roots of 1 minus h plus 2. What happens with the numerator? Four times 1 is 4, and then 4 times h is negative 4h. So you see that 4 minus 4 will cancel, right? And then the negative 4h and the h's divide off. So what are you left with in the numerator? Negative 4. A lot of people would make that mistake. They wouldn't write the negative 4. They would write a negative 1, or they'd just write 1. See how I get the negative 4? That's important. Negative 4 over 2 times the root of 1 minus h plus 2. Can I now plug in the 0? Don't ask that. Can you plug in the 0? Yes. So who cares about reducing? If you can plug in the 0, plug in the 0. Plug in 0, you get 2 times the root of 1, which is 2, plus 2 is 4. You get negative 1. If you wanted to check it on your calculator, you could. Doing the same thing we did before. Okay, we moved to 12. This is the last one we'll do in class. X is 3, so a plus h is h plus 3. The function is 1 over x minus 2. So f of a plus h will give me h plus 3 minus 2, or 1 over h plus 1. Hannah, what is f of a? 1. So I have the limit as h goes to 0 of this f of a plus h is right here, which is 1 over h plus 1, minus f of a is right here, 1 all over h. I put this together a few years ago. One of the calculus classes I had a very difficult time knowing what to plug in where. So I had them set up these three ahead of time so they could write the definition correctly, and then they did the algebra. Whether or not you need that help, I don't know. I just, something I use. I have the limit as h goes 0. What do I have to do? Common denominators because I have a complex fraction. Very good. So you have 1 minus the quantity h plus 1 all over h plus 1 all over h over 1. And then as h goes 0 of, what happens up on the numerator? Negative h over h plus 1. And I'm going to multiply by the reciprocal of the bottom. And what happens to the h's? I'm multiplying by the reciprocal of the denominator. Instead of dividing by a fraction, I'll multiply by the reciprocal. Yep. So now I cross off the h's. I have negative 1 over h plus 1. And I now plug in 0. And you get? Yep, we came up with negative 1 for all of our answers. The answer isn't always just negative 1. So if you go through your worksheet and just do this, negative 1, negative 1, that won't work. Okay. It's always the limit as h approaches 0. Now, can somebody tell me why is it, before we used to do limit as x goes to 2, limit as x goes to 4, limit as x goes to 1. Why is it now the limit as h goes to 0? What does h represent? Think about our first drawing. Very good. So h was the distance between the 2 points. So this was a plus h, and that distance between is h, and we're drawing it to 0. That's why h is always going towards 0. So instead of allowing say this x value to approach 2, we're going to rewrite it and have h approach 0. And that allows it to be much more useful and much more powerful for us. It is. Thank you. Now, wait till you see the proof that we're going to do. Yeah, you can do Pascal's. Right, so this is first degree, second degree, third degree, fourth degree. So you need this one right here. So what is it? H plus 3 to the third? H plus 3 to the third. So you know you're going to have an h to the third, right? Well, when you cube it, you're going to get an h to the third. And then you know you're going to get an h squared and a 3 to the first. And then you know you're going to get an h and a 3 squared. And then you know you're going to get a 3 to the third. Now you insert the triangle. Plus, my coefficients are 1, 3, 3, 1. So this comes out to be h to the third. This comes out to be 9h squared. This comes out to be 27h. This comes out to be 27. How did you know the coefficients were 1, 3, 3, 1? If you take x plus y to the fifth power, you know you're going to get x to the fifth and y to the fifth, right? So you'll get, no, don't even think about the triangle yet. You're going to get x to the fourth and y. You're going to get x to the third and y squared. You're going to get x squared and y to the third. You're going to get x, y to the fourth, right? I mean, it's, your y's increased by 1 each time, and your x is decreased by 1 each time. That's just the nature of the expansion. If you take x plus y and you square it, Anna, you get x squared plus 2xy plus y squared, right? I mean, they got to attach there. So I did the same thing, except instead of a y, I had a 3. See, look at your problem. You got h to the third, and then an h squared 3 to the 1, an h a 3 squared, and then no h's and a 3 to the third. So it's just, instead of a variable, you got a number. That's your expansion. Yeah, and so this is kind of nice because you don't have any, like in the problem in your assignment you have a 3, but here because we have a y we don't have to multiply it out, we just leave it. So you're right, you get 5, or what is it? Yeah, 5. Isn't it 10? 10, 5. I think that's what it is, right? And you did something incorrect. I will come and help you out. So your assignment is due the rest of the